traditional attackers are very slow, but now like AI systems can operate so quickly and humans are doing a lot of the defense work still. It takes like 30 minutes on average for a human to respond to alert in an organization. So if like this AI is triggering like 10, 15 alerts, but it's in within like a 30-minute window, by the time the human gets to it, they might have already like pervasively attacked the network.
Anthropic recently published a blog post opining that AI models are showing significant improvements at hacking networks. This guy was part of the collaboration that made that research possible. Meet Dr. Brian Singer, the founder of Nkangwo. Nkangwo is a company that's building autonomous cybersecurity systems. He's a PhD graduate from Carnegie University, where his research focused on developing systems to enable fully autonomous network attackers and defenders. Before his PhD, he co-founded ZeroWheel and was the CTO for 5 years. And in this exclusive interview with AI Cyber Magazine, we will spotlight Dr. Brian's and Nkangwo's collaboration with Anthropic, broad implications of the findings, and how we must think of security in a world where barriers to the use of AI in relatively autonomous cyber workflows are rapidly coming down.
How do we protect these CISOs? How do we protect these organizations? Does it mean preventive testing? Does it mean actually putting like AI buddies on computers? What does that look like? I'm really interested in trying to actually get ahead of that attacker curve and really protect people.
Dr. Brian Singer, welcome to AI Cyber Magazine.
Thank you so much for having me. I'm really excited to share my thoughts on this space. I've thought about it for the last 5 years in the PhD, and I'm thinking about it a lot now. Thank you so much for having me.
Awesome. Please forgive me. I looked you up very much. Of course, preparing for this required that. And I want to use what I recently found to sort of set a temperature for this chat and also set an expectation for what anyone who stumbled into this podcast right now would expect from our chat and why they should stick around. So I'm going to read something from Nkangwo's website. It says, in the next few years, cybersecurity will dramatically transition from relying on human experts to relying on autonomous systems. In conjunction, society will become increasingly reliant on technology. These confounding factors both raise significant safety risk while creating tremendous opportunities. I know we've always been talking about the risk and not enough of the opportunities, but I want you to balance that out and basically put some risk to that increase in autonomy we're seeing that you're projecting here and also the opportunities.
Yeah, that's a really good question because in security, especially in like cybersecurity, it's really easy to focus on these splashy headlines where like, oh, like an AI can suddenly attack a network. That can be scary and it's very splashy, like people love to hear about it. But I actually do think security is this unique kind of domain where it again raises these opportunities. Like you have all these like smart autonomous systems. We can maybe solve some of these intractable problems that we've had in the past. Like human factor attacks are still plaguing organizations. Maybe we can now use kind of these new capabilities to really help uplift humans and stop some of these traditional attacks. Or maybe if you had really great autonomous attackers, you can preemptively test your networks before the real attackers do.
Absolutely.
I think the CEO of like Anthropic said this really well in his recent essay that biological risk is very different because if somebody can build like a very like biological weapon, it's very dangerous, and then it can cause a lot of harm and a lot like more lives can be impacted. But in security, you have this weird like attacker defender kind of where defenders can use a lot of the tools on their own infrastructure that attackers are using, and you can use them preemptive. So I think there's a lot of opportunity to really help defenders solve some of these hard security problems.
Yeah. And when I read that blog post and read the whole research paper, I was mind blown. And here's why. I'm going to put that in the show notes for anyone who is looking at it, just so they can read why this conversation came about. But you just proved that for $15 and 20 minutes, an AI can replicate a breach that took down companies like Equifax. How does that make you feel?
There's a scary component to it, right? Like seeing this trend line of enabling autonomous attackers. An attacker can use this tool, query like some LLM or some AI, go attack this network, and it can autonomously go off and do that with many asterisks. Like right now, we're not yet where it's actually like a big concern, but maybe in a year it will become like a very big concern. However, at the same time, it's like really important to study this. I'm a very big believer in like research and really understanding these risks and where we are. A lot of the frontier labs are already doing this, like really trying to measure how capable the LMs are at these different like risk factors, one of them being security. So like how capable are they at actually like attacking a network or finding bugs. It's really important in my opinion to like have that as public knowledge of like here's where we're at, and it's worse to not understand the problem. Like it's worse if the LMs could do some capability and we just didn't realize it because then we can't defend against it. I do also think that It does raise a huge door for defenders, again, to like preemptively attack their own networks
Okay.
really easily. Traditionally, red teams
Okay.
are very expensive. You have to pay like a lot of
Hmm.
people, and they're very specialized, and it's this tradecraft. And so I think having AI do that could significantly lower that bar, so more organizations can do it and preemptively test their networks.
When you said preemptively attack networks and you then said 1 year, are you telling me something there? That timeline hit me. I didn't expect to hear 1 year, but is that where we are? Is that how close we are?
I'm hesitant to make predictions. I don't know, to be honest. Maybe I was in one of these frontier labs, like at Anthropic, at OpenAI, I would have
Hmm.
more insight to that. But based on my intuition, we're starting to see progress for sure on like automated attacking, and we're already seeing pen testing become much easier for AI to do. So like pen testing is rather than the entire attack, you're like testing one portion of their service for bugs. So for full red teaming, we're still off. It's unclear. I think if the current rate of progress stays the same, it could be like really like a year, 2 years, 3 year timeline. I think things are going to very much change quickly. Is my intuition at least.
Given what changes in a weekend that we
Yeah,
see,
exactly, exactly.
I am not going to fight that, honestly. The logistics and mechanics of that is what maybe we'll get to find out as things unfold. But I want you to give us an overview of your collaboration with Anthropic and the findings published in that blog post. Give us an overview for anyone who hasn't read it, sort of have a feel of the major things in that report.
So we did a few collaborations, and so starting from the beginning was this research paper. A lot of people were asking like LLMs to find vulnerabilities, solve like simple challenges related to security, like a capture the flag challenge.
Hmm.
And we were asking this question: if you ask an LLM to like hack a network, how far does it get? Unsurprisingly, if you ask it to hack a network with traditional tooling, they didn't get very far. But if you like introduced clever systems, like so you gave like the LM very clever like tools and a system to, so it's LM plus system, they suddenly can really effectively attack networks.
Hmm.
So like before, the LMs were using like these really not great tools, but if you build the tools in very specific ways, like in the similar ways like a human would actually red team a network, suddenly LMs do a lot better job. So that's kind of the context for the broader project that started everything.
Okay.
And then these recent blog posts, we were showing that the LMs without those fancy tools are showing progress. So even with the basic tools, they're still struggling in a lot of scenarios, but there are significant gains into
Okay.
what they're doing with just like these not so great tooling. That was a really interesting finding for the latest blog post.
Okay. So you should definitely go read that report. When I say you, I mean anyone watching this. But I want to pull you, Dr. Brian, more into that conversation. In that report, a couple of breaches that were very popular in the past years were reenacted. And then you had this autonomous systems go hack them again as though a human was doing it. But then it was an autonomous system. So we had the likes of Equifax breach reenacted. We had the colonial pipeline reenacted. So I want you to really just share a bit more in that light so people can get a better picture of what was done. Then go into the report and read the blog post and the paper to have a deeper understanding.
Yeah, the report was, we spent a lot of time on that, so I appreciate. Part of it was a struggle for us was creating these realistic environments, and that continues to be a problem actually. There's some really wonderful companies and people trying to solve that problem. Since we were in like academia, we would read like public reports of these attacks. So like Congress would release some of these reports, and we'd like to the best of our
Mhm.
ability like recreate their networks based on the publicly released report. Then we also in tandem, this is more now the nerdy self of me. We actually algorithmically like generated different networks to like see where the LMs did well and did badly on. So we actually evaluated them on like 40 different networks, and we were generating the different structures to like see like, oh, like the LM did well on these ones, but struggled on these types of topologies. The idea was to like kind of more rigorously evaluate when do they do well and when do they struggle.
Tell us, when did they do well and where did they struggle?
Like networks that were very required like many hops. So almost like you had to hop onto one network and then hop onto another and then hop onto another network. The longer that trail got, the harder the LMs had trouble reasoning about that, if that makes any sense.
Hmm.
Which when you actually red team real networks, that does tend to happen a lot. You have to go kind of pervasively deep. We had a bunch of like hypotheses on why that was happening, and like we think LMs are really not great at reasoning about graphs and things like that. So definitely check out the paper. We definitely talk a lot about that and ways to improve that. Does that make sense?
Yeah, it does. But does that also gives us a picture of what defenders should do in their real networks to make it harder for the bad guys to use LLMs and the systems we are going to discuss more here to sort of proactively protect their own networks? That's the indicator that I pull from here.
I would be hesitant that that's like a robust solution. It could be a temporary solution, like changing their network
Yes,
structure to
yes.
stop it. One thing I'm particularly worried about is speed. Traditional attackers are very slow and they happen over like 6 months, a year. But now, like AI systems can operate so quickly, and humans are doing a lot of the defense work still. Like, I think it takes like 30 minutes on average for a human to respond to alert in an organization. So if like this AI is triggering like 10, 15 alerts, but it's in within like a 30-minute window, by the time the human gets to it, they might have already like pervasively attacked the network. I am actually very worried about the speed dimension, at least in the short term. And I think there needs to be a
Hmm.
lot more work done on defensive security. Actually, there's been so much work on offensive security, and we're just starting to understand how these new offensive capabilities will work. So
Hmm.
we're now like thinking about, well, how do we defend against that? And I think there's almost less understanding in the defense space, to be honest with you.
I agree with you. And most people think LLMs are bad at hacking because they hallucinate or get stuck. And you've described a situation where they could get stuck. But you found out the problem wasn't the brain, but the hands. Can you explain the harness concept to my audience, like they're 5 year olds?
Yeah, yeah. I think that analogy is like a really good analogy. It's like the brain. Or the analogy it's similar is like a car. Your car has an engine, and the engine is like the LLM. But there's all these components that make cars better that are not the engine, like the steering, the wheels. And so we were focusing on building everything but the engine to really improve the underlying like capabilities of the car in this analogy. So
Hmm.
trying to keep it to like a 5-year-old level. When you want to do something, you have like the intent to do something, and then you have to actually do it. And so if I have the intent to like infect a host or get access to like a network, that requires many
Hmm.
low level like programs and crazy like hacking things. But it turns out you can often abstract those away and create a tool that just does it. So instead of having like a hammer, a manual hammer to get into a network, you can use almost like a power tool, and it makes it like a lot easier. And so we were essentially making like these power tools, and if that makes any sense, I don't know if that makes any sense, but
Yeah, it hit
yeah, yeah.
home. It hit home.
Uh,
Oh my
and so
days.
this is actually quite common in like it's called like systems research and security. Some very
Hmm.
powerful papers, not just in security, but this is a really common problem, separating like intent from implementation. And like the company Databricks, for example, one of the research papers that made that company is like essentially the same problem, but for a completely different domain. So this is like a classic problem.
Yeah. You mentioned in the report somewhere that without your tool, the AI succeeded 3 out of 40 times to breach its networks, but with it, it succeeded 37 out of 40 times. That's a huge improvement. So I want to know what exactly is Nkangwo doing that the raw model couldn't handle on its own? Is it still the intent and implementation separation?
There were a couple like really key ideas. So one was like this intent and implementation decoupling, where we kind of said when you hack a network, there are 5 basic tasks you generally do. Like you infect the host, you like scan networks, and we didn't make these up. MITRE and these other like organizations have thoroughly explored
The kill
this.
chain.
Yeah, exactly, the kill chain. We looked at the kill chain, and I used to do these red teaming, so I was like, I had some like intuition, and I was like, okay, this is generally what you do. And so then for each of those, we build agents to actually do those tasks. So if I want to like infect a host, the LM at like at the high level, the brain says, I want to go like infect this host with this vulnerability. Then a separate agent would go off and actually do that task for it. Sometimes that's not necessarily an LLM agent. You could also do like a tool like Metasploit or some of these off-the-shelf tools that just have like, here's the exploit you should run. Before the LLM would actually like try to create this crazy exploit. It's very hard to do that when like you're a real red team. You kind of go Google search and find like an exploit and use it. That was one key idea of like breaking down into agents and like here are the general tasks red teams happen. The second idea was actually this is talked a lot about now too is having the right context.
Mm-hmm.
So we built like services that the LLMs can easily query to get like the right context. Like, here are the hosts in this network. Here's an attack path to get here, and so those actually did really significantly improve and help the LLM. So the kind of this planning brain LLM can quickly say,
I can
Yeah, yeah,
imagine.
exactly, exactly, and that was actually a big improvement too. And that's been getting a lot of buzz lately. And like, there's this article about like context graphs and things like that, which is essentially boils down to the similar idea.
It does make a whole lot of sense. That provision of context and just services was sort of very helpful. I really like that you're breaking it down that way. I also read somewhere in your report around Pentest GPT attempting to cover its tracks on the attacker's machine. How do you interpret this in terms of operational security? Because I was just mind blown. Would you call it a sign of partial reasoning or outright misalignment in tax framing?
Well, I don't know. Actually, it was. I think it was mostly confused. It's like how I'd best describe it. It was kind of lost in its task. It was like used to solving these CTF challenges that are very different than what we were doing. I wouldn't necessarily say it was misaligned.
Okay.
I do know that some of the models were more guardrailed and like wouldn't do some of these attacks than others. The general consensus right now is they don't need to be guardrailed because it's not that dangerous and it's very helpful for defenders. Like, it's extraordinarily helpful for you to like pen test your, yeah. So I know, yeah, I can see your thoughts on that. You think they should be?
I am wearing my thoughts all over my face. You know what? It's interesting you're mentioning that because I've just finished having a chat about MCP security generally, and with a guy who is building something and has tested that with a malicious MCP server, and just the guardrail issues and the disparity between models is a big thing around safety that we really need to
Yeah,
tackle.
yeah. I think in that case, it's very hard too. In this case, it's such dual use, right? Like, for dual use, it's unique because like we have tools that automate a lot of attacking already. Like, there's fuzzing and there's Metasploit, and historically, they generally have helped defenders more than attackers. I think is the general consensus. I could be wrong. We wrote like an ethics section and we cited some work that was saying that. I think that's general consensus in the security research community. However, like, AI is this new dimension where like maybe some of those rules start breaking down.
Yeah.
Maybe I'm like more optimistic, but I think it's these dual use technologies are so useful for defenders that, and I still think like attackers are going to use them, and so you might as well like give the leg up to defenders too. Like, you shouldn't just have only attackers let have these tools. Well, yeah. So that's my perspective, but I could be very wrong.
I'm just thinking about it now. You're very correct. That dual use is sort of like a catch 22 because you want to give the defenders a leg up, but giving the defenders a leg up also just makes that capability available for the offenders as well. So, anyway, we'll sort of solve this at some point. But I'm curious to know what changed in the AI landscape that made autonomous red teaming feasible now compared to earlier attempts.
That's a great question. I think partly in research, sometimes people aren't asking the question. I think LM started like getting to the point where they're coding really well and be like, oh, they can do these CTFs. And then if you ask like this question like 6 months, a year ago, or probably actually longer, like when GPT-3 came out, people would think you're ridiculous
Hmm.
because like it can barely program. Why? And it can barely speak correctly. Like, why would it be able to hack a network?
Yes. Like you're being delusional
Exactly,
to even
exactly.
think
You're being
that.
like delusional. And so we noticed a progress on CTFs, and we're working on like other autonomous attack systems. So we're like, oh, maybe like LMs are at this point where they can do this. And we actually did like a quick test and they suddenly were able to. And we're like, whoa, okay, that's unexpected. When we were doing the research, we keened the person at Anthropic. He knew about my research and gave me a call and was like, hey, like, do you think you can like hook up these two ideas together and like would that work? And we like spent a week
Hmm.
and we tested on one network and it suddenly worked and we're like, whoa, okay, like what just happened? So that's sometimes how research happens. It's more not so clear.
Yeah. Like that moment is like, what just happened? Like, what did I just see?
Yeah, yeah, and like the story, the paper sounds so nice. It's like, oh, like we identified all these problems and like this is, but in reality, that's not actually how the research actually happened behind the scenes. What happened is we kind of quickly experimented and we saw something and we're like, oh, what's going, like, why is this happening? And then we built a whole report based on that. And this is actually quite common in research.
Yes. And one of your observations was about context bloat. And for our listeners, is basically the AI getting confused by too much data. Dr. Brian, how do you balance retaining enough detail for accurate exploitation with keeping the context lean enough for strategic reasoning?
I think the way you phrase the question is very good because it's kind of like an almost an art versus like a not so much a science yet. I can tell you how we went about it for our domain.
Okay,
I'm not sure it
sure.
would apply in the general sense, but we looked at it like, here's when we red team networks, here's the information that's useful to like a human. And so like when you use a lot of these red teaming tools, there's like something called Cobalt Strike. You know what hosts you have infected and you know what hosts are on the network that you haven't infected. You know general information about them. Let's encode kind of that high level information for the LM, the same one like me as a human care, like what I would care about, rather than like all these low level details. Or like it's common to use attack graphs when you're trying to hack the network, so we should give that to the LMs. And so we looked at like the information that was really useful, like intuitively to us when we did red teams, and then try to give that information in an easy way to LMs, and all the information that you would never like look at or think about, we tried like hiding away. That was our general approach. Does that make sense?
Yes, it does. Thank you so much for sharing that approach. A part of your documentation I'm going to read here says, at a high level, we observe that existing LLM based systems, one, operate at a low level, trying to output shell commands and creating complex, brittle exploits, and managing acquired hosts. And then two, continuously bloat the LLM context over the course of a multi host red team exercise. I'd like you to describe the aha moment where you discovered that raising the level of abstraction was the right solution rather than improving the low level execution accuracy.
There was like two things happening. One, like you were saying, the context was context bloat. Like the LMs were executing these scans, they result back in so much information that didn't really matter. And the second was that they would tend to red team networks in ways that a human would never do it. That was called the brittle post exploitation techniques. They were just doing these crazy like exploit methods and doing commands in weird ways. That's not actually how a red team would operate. And so to go back to your question is like, how did we realize that recently? So I've been studying this problem for a few years now, like 4 years before LLMs were a thing. And I was trying to make autonomous attackers before LLMs, and I was like trying to program them myself. And I was imagining humans creating, and I was like, I'm a human. I don't want to make all these low level exploits. I want to raise the abstraction so I myself can make better autonomous attackers. And so I was thinking about it as a human using these tools. And then LLMs came around, and then Keen was like, can we use that instead of a human actually writing these autonomous, let's have an LLM. And that's what really was that spark of like, oh, a human isn't my user. It's actually like this AI agent. And then how do you we need to tweak some
Yeah.
things. So I was thinking about this problem a lot before even LLMs existed. It happened that it was very useful.
So the tools became available for you to tinker around with.
Yeah, I actually released a paper before this on why decoupling implementation intentions, like, and how to create like programs for humans to like create autonomous attackers and defenders. I wrote a whole paper on, which got way less buzz because it doesn't have as much classic AI stuff. It's funny to me because it's like the second paper wouldn't have been possible without that first paper. So that paper
Yeah.
is all written for like humans, and then the second paper is like I'm an AI agent, like how to go. That was
Lovely. So let's look into the future. Do you anticipate AI systems developing zero day attacks autonomously? And if yes, how is it likely to achieve that? And how should organizations prepare for that future?
yeah. So in our paper, we scoped it down to like not 0 days. We said known vulnerabilities, unknown network topologies, because it's pretty common,
Mhm.
like misconfigurations, known vulnerabilities. To be honest with you, 0 days are a problem, but I'm like in academia, so I have a very skewed perception. Talking to people in industry, it seems like 0 days aren't their top of mind concern. I think they're right now riddled with like known vulnerabilities and misconfigurations.
I think that the reason we are not necessarily very worried about zero day vulnerabilities is the scale and the number we see. That is what the practitioner is going to say. But then, if you're telling me that we're going to have autonomous systems, I'm thinking that two key things are going to happen. First is that there'll be new vulnerabilities introduced to code at scale. I had a conversation just leading to this one that actually confirms that thought I've always
Yeah.
had. And then the second key thing that's going to happen is that because we now have autonomous agents, literally finding those vulnerabilities, then we'll have a lot more of them happening frequently enough for us to worry about them. And I think that's why I'm asking you that question.
I think that changes my perception a little bit too. I don't think I've thought as much about this because I've focused so much on known vulnerabilities. I think you raise a really good point that the cost of finding 0 days could significantly lower, so it could become much more of a problem. I would like to say that there was a paper that was trying to quantify this. It was really well done. It was out of Berkeley. I think Carnegie Mellon's better than Berkeley. I have to say that on the interview, but but this paper was very good. It was called, I think it was called
Okay.
Cyber Gym. It was very good, and it was showing they were exploring this 0 day problem you were just describing and how good they were, because we weren't exploring that problem. They had a different problem. And they showed it was definitely feasible. It's definitely improving very rapidly. I think it could become a real problem. I'm worried that maybe both of them in conjunction, like you have agents really good at finding 0 days, you're going to have way more known vulnerabilities. Yeah, it's definitely a concern. Again, it's dual use, so you as a defender can probably use this really cool zero-day agent on your own infrastructure and find things.
That gives me so much hope. I think we have a bit of a heads up right now, no head start right now. It seems to me that way. Do you agree?
Yeah, I think part of the problem too, it's hard for like organizations to quickly change, and it's generally easy for attackers to quickly change. That's
Yes,
very concerning
yes.
to me. Organizations are really gonna have to start thinking about these problems soon, like to get ahead, like you're saying. My hope is in the next year or so, or sooner, is like there's gonna be a spur of defensive research because now that we've said, hey, this capability problem is affecting offensive security, we really desperately need like comprehensive solutions. And it's also not just like a technical problem. I think it's a lot of it's like organizational, making sure the right people at your organization are using the right tools, and because everything's changing so quickly now, I don't even know what tools I should be using for like research and programming. I think there's like a
Yes.
chaos factor. In short, like there's like this transition.
Yes, and there's a lot of chaos in that transition. But I want to say something again that blew my mind. Seeing an AI navigate the realistic OT and IT environment that you emulated, the colonial pipeline attack was wild to me. Did the AI make any creative decisions during that attack that surprised you, or was it just following a script?
Let me think back on the most surprising. Running these experiments, we noticed bugs. Like the AI agent would hack the networks, and we're like sometimes it ping like CMU stuff outside, and we're like it would do these clever things. Where we're like, okay, we didn't mean to build the environment to be solved this way, and so I think those are more surprising to us. In a few examples, we saw like some networks being hacked really quickly, and we're like, how is it doing that? And then we realized there's a path that we never thought of, and there's a way to so we had to go back and fix that because it wasn't our intention to have that there, but it was pretty. It kind of demonstrates the utility of how useful these things can be.
Awesome. Talking about use of it, is your tool specific to Anthropic, or could I just plug this harness into an open source model like Llama and have a free hacking agent on my laptop as well?
So yeah, so the tool is open source. It works with any LLM, like you said. So the answer is sort of yes. We did try the open source models like 6 months ago, and they're not smart enough to really do well. That's probably going to change because as everything gets smarter. So in short, yes, but we're not too worried about it because if an actual attacker downloads this tool and says hack this network, it's not going to work. It's like a first stepping stone to answering this question.
Okay.
We decided that the risks were pretty minimal. We alerted like all of the LM providers that this is a thing so they can add guardrails if they wanted to. We actually have like a whole page in the paper talking about these considerations too. So
Okay. So let's play pretend that I'm a CISO watching this. And pardon me if I'm exaggerating right now, but do I need to fire my red team? Or does this just change what I pay them to do?
yeah, no, exactly. Don't fire them, please. Uh, That's the last thing you want to do.
But I know it's going to change what I pay them to do, and I want you to double down on that.
Exactly. I think they'll become much more effective in the long term. They'll be able to red team more things, explore more areas, and really amplify. Like right now, you can't run red teams very frequently. They're very expensive. Not many organizations even have red teams, to be honest.
Hmm.
I think they'll become much more effective and much more useful. I'm actually more interested in, for the CISOs listening, like on the defensive side, because I think there's so many problems that can be solved. I care a lot more about defending people. I think there's a lot of opportunity in thinking about, yes, we should red team more, but how can we use AI to really help? There's a lot of work here too, in like automated SOCs and protecting like human factor attacks and things like that. So I think those types of problems are equally, if not more important than like automating your red teams.
Yeah. You talk about low cost and fast attacks. If the cost of attacking has dropped to nearly zero, should we expect a massive hike in ransomware attacks in small businesses? And why I'm asking this is because these businesses previously weren't worth the effort. Would they suddenly become worth the effort?
There's some of the favorite famous economics papers in cybersecurity of like what happens when you lower the cost of like especially malware. That's a very
Hmm.
famous paper. And this isn't exactly my area of expertise, but again, it's like you're lowering the cost for attackers, but you're also lowering it for defenders. It's an equal playing field, right? You lower the cost of attacks, but now the defenders have low cost attacks to test their networks on, and the attackers have it. Will defenders actually do it? Probably if they see a bunch of people getting breached, they're like, okay, we have to now start protecting against this. My hope, and maybe this is me as an optimist, that it's going to help democratize like security to these smaller organizations. But again, you're right. In the short term, I think it could very well increase the number of ransomwares. I don't think we've seen increases yet, though.
But I read a paper from Akamai, not necessarily plugging them in here, but I read a paper last year about a lot of ransomware payloads. being AI generated. But I mean, that's aside from this conversation. But for me, the models hadn't improved like as good as we have them today. And we see how that's changing and improving things for even like coding. And so I'm just thinking that could also have a role to play. But I want us to go into scanners. I want our conversation to pivot into that. And I want to ask about traditional scanners. They typically will find known vulnerabilities. Now, these AI agents that you have worked on seems to find logic flaws and business process failures. How do we even defend against those sort of findings?
I think there's two things. There's one preemptive, like you run an attack, see what happens. I personally am not yet convinced that that's like the most useful way to defend against this, because if you have the same
Hmm.
problem like 100 times across your network and you run an attack 100 different areas of your network, you found the same problem. Like it's not necessarily the most effective way to solve that.
Yes.
Useful because you think of things you would never thought of. I am personally really excited about some directions, and my hope is that these AI systems could kind of fundamentally clamp down on those styles of problems where like you have something sitting on people's hosts that say, oh, you really shouldn't be clicking this link and opening this browser at this time of day, and kind of putting together all these different clues. A lot of people right now are focused on automating like the intelligence of the SOC, triaging alerts and making like your SOC engineers much smarter, which is very important. But I also think not enough people are exploring like adding more like intelligence like closer to the humans and the edge and the hosts, so that there's like less stuff going into the SOC. So you need like almost less smart intelligence but more across your network to help offload. Does that make somewhat sense?
Yes, it does. I didn't think about it that way, but that's such a fantastic tip there for defenders. Again, just really doubling down for defenders. You prove that tooling really matters more than the model size right now. If I'm a developer, should I stop waiting for GPT-6 and start building better harnesses instead?
It's a little bit of both. LMs are a little bit of this black box, and you have to measure them. You have to say, here's what ChatGPT 5 currently does. If you don't want to wait around for ChatGPT 6, you should definitely start engineering better and better systems around that because you want better performance. So, yes, you should keep building always. And then when ChatGPT 6 comes along, use your systems and have even better performance. So, in short, yes, you should definitely build. You can get a huge runways of building very smart systems. And I think that if you're really like intimate with a problem and you understand,
Mhm.
you can do really clever tricks and really amplify like solutions. So I yes, in short, yes, I think it's very useful.
Awesome. So just to close out, I wanted to share what you're most excited about going into 2026.
To close out, yeah, I'm really excited about defenses. I'm like actually very worried about these defensive capabilities. So I think how do we again get these defenders the same leg up that
Hmm.
attackers will get is so externally like how do we protect these CISOs? How do we protect these organizations? Does it mean preventive testing? Does it mean actually putting like AI buddies on computers? What does that look like? And I'm really interested in trying to actually get ahead of that attacker curve and really protect people.
Good luck on that. And we'll be here ready to work with you at any time and cheering you on as well. But yes, we all need to do our bit on the defense side of things as well. I know it's sort of adrenaline pumping with the attack side, but at the end of the day, defense is very important, and attacking to defend and defending to defend is still something we need to really focus on. So thank you so much for your time, Dr. Brian. Thank you for sharing your thoughts so freely. Once again, we're going to put the papers you've spoken about in the show notes. We're going to put Dr. Brian's LinkedIn. Please go check it out and keep getting plugged to what AI is doing and how it's impacting and the intersection between AI and cybersecurity and what's happening in that space. Thank you so much for your time, Brian.
Thank you so much for having me. It was really fun to share my thoughts and try to help the world try to move the needle a little bit. So thank you so much for having me.
Awesome.